Good evening and welcome to the Ann Arbor District Library. My name is Steve and I'm going to be your host for this evening. Very soon to pass it off to our colleagues from the University of Michigan. Just to go over a couple quick housekeeping tips. Number one, if you are in need of hearing assisted devices, there are two that are on the back table when you came in. If you need a restroom, if you exit this room, turn right. On the left and right sides of the hallway, you will find two bathrooms, one on each side. For tonight's presentation, this is going to be live streamed, and it is also going to be archived on our website and our YouTube channel if you want to go back and watch any different parts of it. One thing I will also point out is when you have questions, we would ask, and we'll bring the microphone around, we'll ask that you use the microphone so that those who are in our audience watching the stream or also watching the recorded version can hear your question as well as the answer. So without further ado, I'm going to pass this off to our friends from the University of Michigan AI Lab.
All right, thank you. Good evening, everyone, and welcome to Friday Night AI. We are very glad to have you join us tonight. I'm Rada Mihalcea. I'm a professor at the University of Michigan. I'm also the director of the Artificial Intelligence Lab. We started this event about 3 years ago in an effort to engage with you, the community, which we really believe that it's a two-way street. We want to share about what we do, which I think is especially important these days where AI seems to be everywhere, to make sure that there is a good understanding of what AI is and what AI is not. But also the other way around, we are really eager to hear from all of you about what is on your minds when it comes to AI. And previous editions of Friday Night AI were great learning experiences. I know we've been inspired by questions we've heard here or comments that were made, and which really informs the research that we do. As I said, we see AI pretty much everywhere, and it's permeating all major areas of society. We see it in healthcare, we see it in transportation, we see it in law. We also see it, which is tonight's conversation, in education. If it's done right, generative AI can change the teaching and learning process. But of course, the big question is, what does done right mean? And so tonight we'll have a discussion with students and teachers, and experts in education and experts in generative AI to try to answer some of these questions. Ultimately, what we hope to at least get closer to an answer is, with these technologies being everywhere, including in the education process, are we on a path to idiocracy, or are these technologies going to help us to get even better than we have ever been? So tonight I'm joined by several people from Ann Arbor, and we'll talk about the inner workings of models like ChatGPT, and some of you have already experienced that right before this conversation. ChatGPT and DALL-E and other generative systems, you probably experienced them before, but we'll talk also about how they work, and also the impact on education. So we have Kevin Collins-Thompson. He's a professor in the School of Information. He is also director of the Masters in Applied Data Science, and he works on natural language processing, but is also particularly interested in AI and education. Next, we have Kate Hayward. She's the director of research and analytics at the University of Michigan, and she works in the academic innovation. We'll hear more about what that means. Really is a center that has a lot of impact across the world through the educational materials that it produces. And she's facilitating this translational research across the center and exploring novel pedagogies. Next is Andrew Lee. He's a fifth-year PhD student. I've been actually working quite closely with Andrew for the past 5 years. He works in natural language processing. He is very much interested in how these AI systems work and how you can go behind what we see on the surface and understand how they actually work and how they represent what they know about the world. And tonight, him, along with Maya Molai and Ziling Wang, who are in the back, who've been helping, they will run a hands-on exercise for you to experience what these systems do. And next we have Zara Burzo. She's a freshman at Skyline High School in Ann Arbor. She had experience with coding. She'll tell us more about that since an early age. And she played both student and teacher roles, so we'll hear the perspective from K-12 on how these technologies are seen. And then I will be moderated, but I'll myself have worked in natural language processing for 20 plus years. So whenever needed, I can also contribute to the conversation. So before we get started, just a few logistics. The first 10 minutes, Andrew, alongside with Maya and Zelin, will lead you through some hands-on activities. Then after, we'll have a discussion on the capabilities and limitations of generative AI, especially when it comes to teaching and learning. And then we'll make sure to leave plenty of time at the end for you to ask questions. So if you have a question, even in between, make a note, and there will be an opportunity to ask that. So with that, just to give credit, tonight's Friday Night AI is a collaboration between Michigan AI and Arbor Library, and also the School of Information. We have representatives from there, Academic Innovation, and tonight also Skyline High School. And as was mentioned previously, this event is broadcasted on YouTube. So with that, Andrew, if you want to get started.
Yeah, is this on? Can you hear me? Okay. I'm going to stand. So hi, everyone. My name is Andrew, and I have a fun little activity for us. Before we start with our activity, I want to talk about what a language model is really briefly. So again, special thanks to our colleagues that helped us organize this. So what is a language model, like ChatGPT? It's basically a model of language. More concretely, what we mean by that is given a set of words, we have a model that can predict what word should follow. And that's how these models are trained as well. So basically, here's a whole bunch of text data, basically the entire text in the internet. And we tell the model, why don't you try to learn as many patterns as possible that you can identify here. And with those patterns, given a bunch of words, it can predict what word should follow. So it's basically really a very complex probability model. And we kind of have this model in our world, in our brains as well. So if you see a phrase such as to be or not to be, that is the blank. Anyone want to? Yep. Question? Yep. So that's, you know, a reflection of how our minds work. Another example, that's one small step for man, but a giant leap for mankind. Exactly. So that's kind of an analogy for how these language models work. Based on these sequence of words, what words should follow, based on all the text data that it's ever seen, it's going to try to make that probabilistic prediction. But because of how these language models are trained, basically next word predictions, it can lead to what we call hallucinations, which is sometimes unintentional, made-up facts. And so perhaps we give it the input, Andy Pandy was born in blank. Well, and let's say Andy Pandy, this person or character, doesn't exist. But the model has to say, well, OK, according to the sequence, I'm going to guess something like either 1991 or maybe like Ann Arbor, Michigan. And it's going to try to fill in the blank, whether it's factual or not. And we call this behavior a hallucination. Some more examples. John Handsome is a famous blank. Maybe John Handsome is fictional or made up. And so then it's going to try to fill in the blank with something that's not true. Right? And so in the text data that it ever saw, it's very unlikely that it saw something like Andy Pandy was born in, I don't know, who's Andy Pandy, right? That's not a sequence of words that it probably saw. And so it's going to guess, OK, probabilistically, I'm going to fill in like a year or location in this blank. So this is a common phenomena that happens. We refer to this as hallucinations. And it's, I'm sure we'll talk about it today, but it's something that we should be aware of, either as students or teachers or just end users. This is something we should be aware of when using such complex models. So with that introduction, what we have prepared is a handout that I believe every one of you guys should have. And basically, there are either 3 or 4 examples of um, passages that ChatGPT generated. And I'd like to ask for you to meet your neighbors, introduce yourself, and try to identify as many hallucinations as possible. So you might have to, pull out your phone to Google stuff, or maybe you're an expert in in the area that we've or in the areas that we prepared. But yeah, so let's just take some time to try to identify examples of hallucinations. Um, and as a treat, at the end, if you identify more than, we're not going to say the exact number, but more than however many examples, then you are qualified to submit your solutions, and you'll be entered into a raffle where you can win a free t-shirt. So try your best. Try to explain to my parents.
Yeah, only a few times.
Yeah.
I feel like students are engaging with that.
That's very interesting.
Okay, let's just take one more minute. Okay, so why don't we spend some time talking over some of the hallucinations that we might have found? Um, any volunteers to share any hallucinations that they found? Okay, so there's one in the back. Yes. So, funnily enough, on my way here today, I heard from the audience someone gasped, "Wow, Edison was born in Michigan? I didn't know that." That's a perfect example of falling victim to a hallucination from these language models. What about from the second passage? Any hallucinations identified in the second example? Yeah. Yes. Good. The Bears don't even play in the AFC, right? So, um, yep, that's a good example of a hallucination. And then what about in the third example? Did anyone get there by chance? Yeah. Yes, yes. So neither was the library, to my knowledge, built in 1907, and neither was it related to Andrew Carnegie. um, yeah, great. So these are all, I think, examples of hallucinations that you've identified. Um, and really, the takeaway that I want you to have from this is these language models are built to generate what's plausible, right? And plausible is different from factual. This is, I think, a very important distinction that we should keep in mind. Whether you're a student trying to gather information or learn, or whether you're an instructor trying to understand how to best use this tool for teaching or for your students and so on. I have a fun food for thought, and maybe this will come up during our discussion, maybe it won't, I don't know, but just curious, how many of you guys used Wikipedia as your, um, a lot of hands actually, yeah. And so you probably all know that anyone can go in and edit Wikipedia articles. And so how do you know someone didn't use ChatGPT to write that Wikipedia article? Which raises questions on like, how do you know what's perhaps factual or true, or what should we think about when we start using like open source tools like Wikipedia? And so that's a question that I'd like for you to maybe think about later today. All right, yeah, that's all I had prepared for today. Thanks. Oh, right. So at the end. Okay, yeah. So if you think you have more than 8 correctly identified hallucinations, feel free to write your name, and then feel free to submit to Christina in the back, and then you'll enter a raffle. At the end, we'll draw, was it 3 or 4? 3. We'll draw 3 random raffles, and then you might win a t-shirt. Thanks. Does anyone have more than 8 hallucinations? Okay, we'll change that number to 5 then.
That's just how good the hallucinations were.
Yeah, yeah. Hi, so I'm a PhD student working on language models. In particular, I've been studying how to either build or adjust language models such that they can be used in domains like mental health. Of course, like healthcare in general is a very sensitive area, and so you've already seen like how language models can make up stuff. And so especially in sensitive domains like mental health, we really want to avoid misdiagnoses because of AI models. And so I've been studying how to really understand how these models are reaching their decisions and how to make safer models for those reasons.
So I'm the Director of Research and Analytics at the Center for Academic Innovation. Our unit works to reimagine what higher education could and should look like. Three of the ways we do that are through building novel educational technologies. If you've heard of Atlas or Gradecraft or eCoach, those are things we build. We make innovative online learning experiences. So we've partnered with places like Coursera and edX, and also we're building our own platform, so Michigan Online, to make the knowledge of our amazing Michigan faculty accessible to people around the world and here, right? You don't have to go back to college to go take content from Kevin, right? It's an incredible opportunity to really get our expert knowledge out and accessible to the world. And then my team gets to do research across all of those things. I get to look at what people do in these online courses, how they're learning. I get to think about how students are impacted by eCoach and Atlas. And already we're seeing ways that our team is dramatically impacted by Gen AI and can leverage these technologies, from taking a qualitative coding project that would take a pretty long time to go and really sense make student feedback and create a sense of what was said across thousands of responses. And we can do that in a much faster time. And we're doing that in such a way that we're documenting it as research that we can share so we can help other people understand how valid these things are. Another way that I have personally interacted with Gen AI, I got to know Rada through our work on the university committee, trying to help the whole university think about how it should be engaging with these technologies. And one of the ways that we really spent some time thinking there is thinking what instructors are going to want to use this technology for. Places where they're going to be excited and thrilled to integrate it, and places where we're going to want to be mindful and say, no, actually, I want you to not use that technology there, right? So we really considered a spectrum of ways and have thought with a lot of other faculty across campus about how they want to approach it. So those are some of the things we've been thinking a lot about.
Thanks, Caitlin. Hi, I'm Kevin. As Rada mentioned, I'm a professor at School of Information. So it turns out that I've always been fascinated by language, by what it can express, by how people learn language. And so my PhD is in language technologies, and I worked on language models before they were cool. So it's been fascinating to see how they've evolved. And so in my role at Michigan, I've worked closely with Caitlin, for example, as the director of the Masters of Applied Data Science program, which is a completely online degree, and it's an international degree. So we have students from all over the world. And it's not only a great, we have incredible students in our program. As a researcher, it also overlaps, we have incredible opportunities with generative AI to really help understand and support both instructors and students, in our program in particular, and also, of course, other opportunities at Michigan. And so the past year has been quite a whirlwind for me. It's been fascinating to follow how, I got interested in large language models when GPT-2 came out, and that attracted my interest. But then I got rumblings about a year ago from my colleagues at Microsoft Research that something big was happening. They didn't tell me a lot about it, but it turned out that they were getting internal releases of GPT-4, and then eventually they came out with a paper in March that describes all the experiments they did, which were fascinating. And so it's been fascinating for me because these models, people still don't really understand a lot of what they're capable of. We're only now just learning, literally week by week, new papers are coming out to understand what large language models are good at and what they're terrible at. And they're terrible at some pretty basic things, which we can talk about later. But so anyway, yeah. So I have a role both as an educator as an administrator of the program and as a researcher that kind of intersects, all three of those intersect my interest in generative AI.
So with that, we did see a little bit of ChatGPT, and Andrew mentioned briefly about language models, but still just to have a common understanding for our discussion tonight. Maybe Kevin, if you wanted to add something on the description of how language models work.
Sure.
I think that should also work, that microphone.
Okay, cool. So as Andrew mentioned, the idea of what large language models are doing is incredibly simple, and you see similar examples on your phone when you write a text message and it is all trying to auto-suggest and correct, or if you're writing, if you're doing a search, it's trying to suggest how to complete your query. So types of language models have been used for a decade or more in tasks like that. And the idea, so these large language models are doing a version of that, essentially. They're just learning how to, given a set of text, how do I figure out what the best next word is? Given all the text that came before, what's a reasonable continuation of that text? So the idea is quite simple. The fascinating thing is that the task of predicting the next word in a sentence, if you think about it, to do it well, a machine has to have a pretty sophisticated knowledge of the world. So the difference between the models that you have on your phone or that you use on search engines, they sort of look at very short snippets of text like your query or your text message. But the size and the sophistication of the language models that we see, like in GPT-4, just to give you an example, like there are probably, I don't know, maybe a few 100 million parameters in some of the models, if that, in some of these smaller auto-completion models. But a model like GPT-4 has over 100 billion parameters, which is about the same number of neurons that we have in our brains. I'm not trying to say that brains and large language models are similar in the way that they process information, but it's the large models, the scale of them, allows them to learn incredibly sophisticated models of the world, all in service of predicting the next word in the sentence. And so, I'll give you just a brief example of kind of how they're structured. So, if you think about an example like, my favorite food to put into the toaster is blank. Maybe some of you, there's a long list of things you could put into a toaster as food, but to think about what makes sense to go in there, how do you, there's things to do with the fact that, if you take some random object, well, it has to be food, it has to maybe be something that we cook, it has to have a certain size and a shape to fit into a toaster. And so in order to learn those properties of things so that you can make a sentence that continues correctly, you need a lot of information about the world. And so these language models are trained, like GPT-4, for example, was trained on 10 trillion words of text. And they get all that information from their huge standard archives of the internet. There are archives of textbooks, social media sites. I mean, it's sort of like a giant vacuum cleaner that sucked up immense amounts of information. And by seeing what people put into toasters, it kind of gets a feeling for a sense of, okay, so of what properties make food appropriate for toasters and so forth. And the way that the interesting thing about these large language models is you can think of them like a stack of Lego layers. And so the first layer, it's built with a building block called the transformer. And I won't go into the details of what a transformer, how it works, because it's quite complicated. But essentially a transformer learns, if you give it a sentence, what are the important words in a sentence that are useful for predicting the final word. So in the case of my example, the word toaster would be a lot more important than the word what. So if you build a layer of transformers, the first layer of the transformer learns about what foods people put into toasters, okay? But then the second layer of the transformer looks at all the foods that were mentioned, that were put into toasters, and it sees how they were used in other contexts. And it begins to form associations between not just about things that were put into toasters, but how that food was used in other contexts. And it learns that certain foods have certain similar properties based on their color, their size, their shape, whether they're heated or not, and the second layer. And then the third layer might learn even higher level properties of how these foods are organized and what they're used for and so forth. So GPT-4 has 120 of those. Well, they don't make it public, but from what people have leaked, it has 120 of those transformer layers. So it's learning an incredibly high-level view of the world trained on an immense amount of data. And so at the end of the day, when you ask it to write a story about your breakfast, it can go back quite a ways into it can deal with a lot of text in the context. It can see what's going on, and it can take into account both the low-level factors about what goes in toasters, but also what was talked about before, what the trend of the story is that you're telling. And so that's the real power of these models, is that they, over 100 billion parameters, they've encoded some view of the world that lets them predict these next words very accurately. But in that process of doing that, it learns a complete view of the world that's incredibly sophisticated. And people have been spending a year trying to figure out. So in that sense, it's a bit like a brain. People have this incredibly complex thing. They've been trying to figure out what it can do. So here's an example of something that just last week, they published a paper on the fact that language models can't, it's called the reversal curse. So for example, there's something on the internet that says Tom Cruise's mother is Mary Lee Pfeiffer. Okay, so if you ask it, ChatGPT, who's about that, you can say Tom Cruise's mother is so and so. But then if you ask it who is Mary Lee Pfeiffer's son, it fails completely. So if you reverse it, it learned about A is B, but if you ask it, give it B, it doesn't know that B is A. So people have just discovered this. It's also terrible at math. It's terrible at a lot of things, but it's also incredibly gifted at some things. And it's been a process of discovery, given how complex these objects are. So one of the messages is that we're still learning about the capabilities of things and how to measure them at a basic level. So there's a lot of excitement about what they can do. So one thing I would counsel is that sometimes there's a lot of hype in the media. People will pick examples of things that are brilliant, but these are sort of anecdotes, right? It's easy to find things that you're looking for if you just look at anecdotes, but what's really needed is sort of consistent scientific exploration that goes beyond anecdotes to really get at what these systems are capable of. So.
Thank you. That was a very extensive answer with a lot of insight. And just very briefly, since we keep talking about language models, but there is more than just language models. There is also generative AI and vision. And do you want to say briefly on exactly what it is?
Sure. So just like how ChatGPT is we call it a generative model, as in it's generating text. You also have generative vision or image models. And the high-level idea of building such models is the same, where in something like ChatGPT, you give it text data and you give it blanks. So like something like to be or not to be, that is the blank. And if the model guesses a word and if it's correct, then you reward it. If it guesses and it's wrong, then it tells it to try again. It updates the parameters of the model and asks it to try again until it gets it right. And then, so basically the task is fill in the blank. And the idea is the same for image models. You have images, which are, of course, in terms of computers, they're just pixels. They're just a series of pixels. And so what you do is you randomly kind of just swap out or mask out or blank, make these pixels blank. And you tell the model, okay, give me your best guess on what color this pixel should be. And then you do that with enough image data, and then just like ChatGPT can guess what word should go in the blank, these image models know what color should go in certain pixels of image. And so you can use that model to then generate images that match users' queries. So yeah, that's kind of like the high-level idea. There are a lot of parallels in text generative models and image generative models, but that's the high-level idea of how to build one.
Thank you. So with that shared understanding, we can now move on to some questions and answers about the generative AI in education, which is today's main topic. And so the next question will be, how are these systems being used by students and teachers? And I will start first with the K-12 perspective. Zara, you can give us some insight into how you use ChatGPT or how you know that others have used it.
So me personally, I don't heavily use ChatGPT, but something that kind of marked me was last year. I had written like a story, and I just needed a title, and it was due that day, and I had no title. I mean, I had a bunch of options for titles, and so I went to ChatGPT on Snapchat, and I ran them through, and kind of asked it to help me, and it came up with it helped me come up with the perfect title, and I put that into my story and turned it in, and then the teacher very specifically commented on how much he really liked my title, and so it left me with that. But shifting away from me and just in general K through 12, it's ChatGPT and generative AI is really useful as an asset. It's like having a study buddy, like your friend is sitting there except your friend is your computer screen, and you can so many things. Like you can run your writing through and what you've written, and it can give you feedback. It can give you suggestions. It's not like Grammarly where it just tells you, oh, this is wrong, oh, this is right, oh, you should fix this, you misspelled this. It can tell you, oh, well, maybe you should do this, maybe kind of change this, or it's not persuasive, or whatever it is. And with math, it can give you different ways to go about the problem. It's also like having a teacher there, like you're back in the classroom, and it's telling you, give you examples of the problem and different ways to think about it, and with language help you memorize and whatever it is. And overall, it's a great asset to have. If you have it and you use it properly, you can know, it can help you be the best that you can be, and you can know the most and learn the most and just reach the highest level you can.
Thank you. And there are indeed very many ways in which we can think. Thank you. Zara mentioned a few, and Kevin, you were saying that we are just learning, so I think there is a lot to learn about how we can use these tools. Kate, do you want to give us the college perspective from your experience on how these tools can be used?
Absolutely. So I'm staff at this point, so I'm not typically using it in the classroom. I am seeing instructors use it as part of assessment, right? Trying to get a sense of different aspects of student work. And that I think is going to continue to grow and change as we learn more and figure out where we do and don't trust it. I'm seeing it, I think Ethan Malik of Wharton described it really well in a paper that came out, I think last week or the week before, as a job leveler, right? And so it's gonna help people who are sort of in an introductory space just get much better, much faster, similar to what you're talking about, right? You're able to do things faster, even if you're starting from a fairly introductory perspective. So, and then people at a more intermediate or expert level are finding more efficiencies, right? You're able to do something faster. Even if you could have spent an hour writing that tough email, it gives you a first draft that you can hate and iterate and make so much better, right? So I'm certainly seeing lots of that. Research, meeting agendas, I'm seeing people use it for interview protocols. I'm seeing people use it to do introductory analysis, right? Seeing what you can see from that picture. So I think, and then certainly we are hearing from students that they're using it very pervasively. And then you open up lots of conversations about expectation setting, what instructors are telling students they can and can't do, and what it means when somebody does or doesn't follow along with that, and what should happen in that alignment. But I definitely am hearing from college students and people who have recently graduated that they're using it very broadly in their work.
with all this that we are doing, a lot of the promise that we see from AI is this idea of personalized education. And given also the certain disciplines where there is an increasing number of students, perhaps not surprisingly, for instance, there are more and more students who want to study AI. But with this large number of students, it's very hard to actually do personalized education. So Kevin, can you perhaps just like briefly hit at some ideas that we can do to pursue this path?
Sure, thanks. Well, one thing I want to say about personalization actually is that while a lot of effort is being put into how to personalize for students, I think there's also great potential to personalize for instructors. And what I mean by that is, give instructors personalized feedback on what's going on in the classroom, activities that could help, help the students, maybe how they could improve presentation of a topic or things like that. Language models seem to be pretty good at, they seem to have a pretty good, given all the trillions of words that they've read across all these domains, they seem to be pretty good at understanding kind of what what are easy parts of a domain, like in math, and what are the harder concepts, and how the concepts depend on each other. And so there's a lot of potential, when you connect that with a model about what students want and what they need. So what are their career goals, and then what are the teaching goals that we have in a particular class. We can create tools where the instructor is not out of the loop. So the goal is not to replace the instructor. The goal, like for example, in the MADS program, in this master's degree, we have classes of about maybe say 150 students. It's all online, and I view generative AI as a way to leverage the expertise of the instructor in a way that allows them to help more students, give them more personalized feedback on their specific assignments in a way that just wasn't scalable before. For example, we can now reliably run generative AI on students' code submissions, because GPT-4 is not only very good with human language, it's pretty exceptional at describing problems if you give it a Python program. It's very good at debugging. It's not that we want to tell the students exactly how to, you want to maybe hint about how to fix it and so forth, but we can give better feedback now. And so I think the combination of those things about having better models of what students' goals are and what their difficulties are likely to be, along with the much deeper models of content, and then advice for instructors. That's kind of how I see the things progressing, and we're trying to do some of that in our work at the School of Information.
Thank you. And we'll do just one more question, and then we'll open it up to the audience for questions. So please think of the question that you want to ask. The final question I want to ask is, what are some of the dangers of using AI systems in school? So specifically thinking, for instance, for students, Zara, what do you think would be the possible downsides?
So obviously ChatGPT and generative AI is really easy to use and access, and it's free online, anybody can open it, which also means that because like middle schoolers, high schoolers, whatever, K through 12, get a lot of assignments and homework where you have to write or choose. And if you have this thing that's know-all, then you can just quickly type in whatever question you need, and then it'll give you an answer you can quickly put in. And this obviously has the effect of you not knowing like whatever the question was asking. Like the whole point, it gets rid of the whole point. When you're somewhere to learn, school, if you're not learning, then like, yeah. Also, ChatGPT is like an easy button where it's like literally on your computer, a button where you, even if you have like a problem that you say, oh, I know how to do this, like it's just, it'll take a little bit too long for me to do it, so I'll just quickly put it into ChatGPT and it'll do it for me, and over time you're gonna gain a dependency on it, and you're gonna lose motivation to do it, you're gonna lose incentive, and you're just gonna get lazy, and you're not gonna wanna do it by yourself, because, oh, ChatGPT can just do it for me. And also, ChatGPT is literally just the internet all compiled, and obviously the internet has misinformation. So if what you're learning and what you're going off of is all just generative AI, then obviously some of it is going to be wrong. And also, like Andrew said, it has hallucinations and it can just completely teach you something random and you just believe that, and then yeah, you're just random information that came out of nowhere.
And Andrew, do you have anything to add to that from your perspective?
I guess for myself, like if I think about when I use ChatGPT and when I don't, so ChatGPT also knows how to code. I think Kevin brought this up, but like if you think about Python language, it's not like natural language, meaning it's not English that you and I speak, but Python itself is a language as well that ChatGPT has modeled. And so I saw a funny meme actually about like these entry-level software engineers that are saying, oh, it takes me like 10 minutes to do my job now. But then at the next like senior level, it's like, oh, someone used ChatGPT to write their code. Now it's going to take me like 8 hours to debug it. Because just like we saw hallucinations in English, if it hallucinates in Python, it's very subtle, and it takes time to like we have a Wikipedia to like read out these hallucinations. But the more like domain specific it becomes, like the more it becomes difficult to read out these hallucinations. I don't know if I'm answering your question, but I forget where I was going with this, but oh yeah, right. So I think depending on like, I think there are cases where it's appropriate to use such models. Like something specific like programming, maybe it's not so appropriate, but maybe it's something like, hey, I need to write this email. Can you reword this for me? Maybe that's appropriate. I don't know. And so when it comes to teaching, I think whether it's the student or whether it's a teacher, like thinking of whether it's an appropriate use case is an exercise that we should get used to. Like from a student's perspective, it's a separate question whether they see it or not, but whether they think about, oh, is it a proper use case to have this model do my homework for me? Probably not. But these are questions I think we should be asking ourselves, like whether it's a proper use case or not.
All right, thank you. So with that, we can open it up to questions. Yes, I suggest using the microphone.
Yeah, again, if you have questions, if you wouldn't mind coming over to the microphone and speaking in the microphone.
Thank you very much. Quick, 2 questions, unrelated, but one.
Well, maybe take one at a time because I think
it is somehow related. It's on the opportunity and on the trade. So on the trade part, I was wondering what the panelists think about the social, cultural, economic inequalities and issues this generative AI can produce or reproduce. On the other side, with the opportunity one, I was wondering how this can be useful in humanities or creative writing or artists. And I don't see much of those applications being discussed from GPT or other sources. Thank you.
So does anyone want to take the first part and then the second part? I can also say a few things on the socioeconomic part. It's something that we've been exploring in my lab on how these systems actually are not necessarily equitable when it comes to representation of different cultures. So they are very much weird in the sense used in psychology. So it's Western, educated, industrialized, rich, and democratic. So we see heavy representation of Western civilization, for instance, but when you ask even things like common sense, the representation from other cultures is really not the same there. We also see the same for language vision systems. Students have been working on seeing how well these systems would work, like for instance, systems behind DALI. If you try, for instance, a mundane question of can you recognize this object, and you show it a refrigerator, if you show an American style refrigerator, it's going to do very well, but if you show a refrigerator from other countries, it's going to fail. And that's because not all refrigerators are the same, despite what we think in this room. And so they are not. But with research like the kind that we do and others do, pointing out to these limitations, and that was a great question, we are hoping to address that, to think of ways to get the right data for that. And then for the creative piece, Dara, do you want to say something about writing or somebody else?
Well, for writing, I've kind of tried to run my writing through, and it's like, it's really good for like giving feedback and telling you like what you would, I don't know, what you need to add or what you think, what it thinks you should take away or whatever it is. But for like art, I haven't tried it, so I wouldn't really speak on it.
I can add something quick on the socioeconomic gap. And I've used the term digital divide amongst my friends. And so if you think about when the internet first came out and Google was easily accessible, basically the internet is information, and so those who had access to internet have much quicker access to information and can advance their careers or knowledge or whatever with that information. And I think we're seeing something similar with AI now, where those who have access to, say, ChatGPT or these AI models have, again, better access to better information. And so like the examples that Zara gave, if you really know how to use these tools for your advantage, then that's an advantage that you have that maybe some others don't. And so I think this digital divide may be growing and something that we should be aware of or be thinking about.
Yes, thank you very much. I had the experience of the language model from Kevin and the hallucinations from Andrew, and so this pertains to that aspect of it. Everything that comes into my world about artificial intelligence seems to be, especially ChatGPT, has to do with prompt engineering. Is there a theory that's emerging based on the idea of what the language model is that would allow the ordinary users to become more proficient at being able to do prompt engineering effectively?
Well, that's a great question. That's an area of active research for sure. There's a lot of work going on right now to in algorithms that can explore the space of prompts automatically and efficiently. And while it's exploring the space of possible prompts in an intelligent way, maybe you give feedback to the user so the user can give feedback to say, no, that's not really the right direction. Try looking in this other direction. So that's literally something that's happening. There are papers being published now about exactly what you're talking about. And I think it does bring up a very good point, which is that a lot of the emphasis so far has been on the technical machine learning side, crunching through these models and what they could do. But there's a big part of computer science called HCI, human-computer interaction, which studies how people interact with these systems. How do people develop trust or mistrust of the systems? How can they understand what the systems are capable of and predictably work with these systems? And I think right now in computer science, I think the HCI community, who are experts, have been looking for decades at how people interact in conversations and dialogue systems, for example. There seems to be a disconnect now between the machine learning people are off doing their thing, and those communities aren't talking to each other, and they need to do more of that. And I think they're going to need to do that to address the scenarios that you're talking about.
Hello, I'm Lee. I'm an associate scientist at Sortech, so say hi to John for me. And at Sortech, we're already using large language models to generate educational materials, not directly for students yet because we don't trust it enough, but maybe as like an aid to teachers if they're writing content and be like, okay, I just need a multiple choice question about this, and then it can generate it for them, and then they can fact check it. But right now, we're running into the problem of like, is this an actual like factual thing it's giving? And we have a whole manual team to review the responses. So I think the next level of large language model is there needs to be a fact-checking layer after it so it can actually check what it's telling you. To you guys, what do you think that fact-checking layer would be? And if you can tell it to me, I can implement it at work, so
I could say something briefly. So there's an area of computer science research developing data structures called knowledge bases. And a knowledge base, all it is just, you think of like a big network, and every node in the network is an entity, let's say Barack Obama. And connections between the things in the network represent the relationships that Barack Obama has with other entities. So there's a very active effort right now to build knowledge bases that represent verified sources of knowledge about entities and how they're related to each other. And more than that, there's an effort to connect large language models with knowledge bases to do exactly what you're saying. So the knowledge base is a trusted source of facts, and it can verify what's being generated against what's in this trusted knowledge base.
So I can bring this up in the next Scrum, you know. Make sure that, okay, continue.
That just makes me think that you're going to need a way to pick which knowledge base you're working against, right? Some people are going to want to say, I'm playing this against Wikipedia. Whatever that Wikipedia currently says is acceptable. But we've had so many debates about what facts are in the last decade in the US. And that goes back to the cultural component of the ways that common sense and understanding might be profoundly different in different spaces. And we're going to need a way to inform how we want it to understand truth.
Hello, my name is Carl. My name is Carl. I wanted to responsibly and excitedly relate that I have a severe social disorder from algorithmic harm from private AI. And so it's very gratifying to see people talking about these things publicly and informing people. I was a hobby software developer, and I looked into a number of these AIs, and I looked at them online, opened up the Python code and tried changing out the algorithms. One of the things that I've observed is there are a number of ways to get it to report its confidence on different tokens, different kinds of models. And it's interesting to note that they don't reveal that information in the commercial AIs. I was curious if you have heard of anybody putting human impact into the reward or loss functions when developing these AIs, things like test scores, wellness, conflict versus connection. I think that could be very powerful.
I can talk a little bit about research, and so I've been trying to study how to build language models or dialogue models that know how to be empathetic, and a lot of what you talked about, like basically rewarding the model the more empathetic it sounds, or trying to encourage the model to be more empathetic. So a lot of that actually boils down to trying to find empathetic data to mimic. Or there's this term that we call grounding, which is like here are like the dimensions that we want the model to care about. So like empathy, and we can even break down empathy to like cognitive empathy or emotional empathy and so on, and try to have the model decide what to say based on these dimensions. That's just one example. I think a lot of my friends in this space are looking at startups that can build personalized dialogue systems with this in mind. So having like a personal well-being coach, like, did you, like you and I, so the user and the model, they might agree to say, okay, like 3 times a week, I'm gonna promise to like journal, or once a day, I'm gonna promise to like go on a walk. And so to have like a personal agent that can kind of keep you accountable or keep encouraging you to like do these exercises for your own well-being. I think a lot of people have interest in building such personalized agents, and I think the questions that you asked are the same questions that they're asking, like how do we build these dimensions into our models?
So we can take one more question. So next.
Yay! Yeah, thank you for coming and speaking. And my question was about bias, whether that was algorithmic bias or bias that stems from the training data. And I know that we've seen a lot of examples of bias showing up in many different types of AI models, whether that's for medicine or hiring or blah, 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 blah. And I was wondering, are you seeing any kind of examples of bias, or do you predict there being any form of bias when it comes to kind of having tailored or specifically catered education for students, because I know that using generative AI for education, that has a huge potential to bridge a lot of gaps and to, what was the word for it? Not tailor, but personalize, thank you. To personalize education and kind of create opportunities for something like learning disabilities or any barriers that were there for learning, where like traditional teaching does not kind of really go past those barriers. But I'm also wondering, are there any forms of biases that are a concern within the education industry when it comes to AI? Just very curious. Thank you very much.
I mean, I think to build on Rada's earlier point about the weirdness of the corpus at the moment, you've absolutely got the content is not broad enough to, it's absolutely biased, right? It's deeply biased. And so then you have a question of how do you get more diverse content in? So hopefully that piece is addressable. The challenge is that until we do that work, if you're the recipient of what the model hands back to you, how are you paying attention to it? What trains you? What teaches you? Where's the teacher teaching you to critically investigate this and to go learn about the breadth that wasn't surfaced back to you, right? So you've got real critical thinking and skill development there that we're gonna have to teach a whole generation and all of ourselves, right? It's not just a younger generation, it's all of us who are using these technologies to really engage with and think about that. I think,
All right. With that, I think we are past time. We'll still have devices at the back of the room if you want to try for a little longer until the library closes. Actually, they close at 8. To try some of these tools. I hope you got some food for thought from tonight's discussion. In general, I believe there is a lot of potential in these tools. They do have biases, they are not perfect, and we are still learning on how to use them. But eventually, as we've seen in the past, we've seen how AI can actually be very effective teachers for very specialized domains like chess. And I think tools like ChatGPT, DALL-E, and others do have the potential to become those kind of partners in us learning better, again, if we use them right. And before I conclude, I believe we do have maybe, we have some winners for the, Christina, do we have?
Yeah, that's what I was going to.
Oh, you are, sorry, I'm sorry.
Yeah.
Okay,
Right.
I was just looking in the back too now, so please.
So 6 of you return your papers, and I have some t-shirts for you. Please come to that table at the end and pick up your t-shirt.
All right, so with that, many thanks to the Ann Arbor District Library. And also to the panelists and Christina